Good evening, everybody, and once again, welcome back to the video. I hope you guys are doing fine. And in this video, I'll try my best to essentially teach you about Unify Your Event Data, a guide to mapping events to a standardized format. For this project, we are going to take a use case or an example of IoT devices, right? These IoT devices are essentially submitting or publishing data to a topic. Maybe it's coming into the Kafka or Kinesis, doesn't really matter, but eventually they're landing into the raw Apache Hudi transactional data lake. Now, what happens is basically in the event name, let's say you have high temperature or temperature high or critical temperature, but these all corresponds to basically a standard, let's say high temperature, right? So what you want to do is you want to essentially map these items to a standardized format, right? If you don't find the mapping, maybe you want to essentially use a default value. So in this video, I'm going to teach you how to essentially do the mapping incrementally, meaning we're going to have a mapping table which is going to hold mappings. We're going to have events table which will hold the events which are coming from IoT devices, right? And then we'll have a date dimension. So we're going to incrementally basically fetch new data in the event table. We're going to join that with the mapping table, and we're going to join that with the date dimension, and we're going to populate the fact or the normalized table. So that is what we're going to build. This is a classic example of a lakehouse architecture. So let's get started with the project. So now we're going to dive deeper into the project and the code. So the first step of the project is we need to define imports. As you can see on my screen, I defined OS, sys, UID random. I defined PySpark, a Spark session, Boto3, JSON, and a datetime object. Now the next step is we need to create a Spark session, right? So you could essentially create a Spark session with this command. So here you can see I'm submitting a package and I'm using Apache Hudi version 0.12.1 and the Spark version is 3.3. Over line 7 to line 12, I'm creating a simple Spark session and I'm printing the Spark session on line number 14. So to teach you the concept, I'm going to define a Python function which is going to generate some fake data. So let's take a look at the Python function. I have a simple Python function which is called generate IoT sensor data. This takes total number of devices, total number of sensors, and the number of entries. And the job of this is again to generate some fake data. This is how the data looks like. You have a sensor ID, you have a device ID, you do have a timestamp, you have a unique identifier which is a GUID, and then you have an event. So for example, temperature exceeded, temperature spike alert, temperature exceeded, temperature danger alert, right? These are different events, right? And I essentially want to map these to a standard value. So hopefully the data set makes sense. So this is again the events data which we will be normalizing. Now that you have seen a sample preview of the events data, now we need a date dimension. So I'm gonna be showing you the code for that. The code for date dimension is pretty straightforward. I define the min and the max date. Basically, this is gonna generate the date dimension for me. As you can see, the dimension has a data key, a year, a month, a day, a quarter, weekday, and a weekday number. So the date dimension, people can use the date dimension to join with the fact table and essentially perform aggregates and say, okay, show me the events over a month, show me the events over a year, show me the events over a quarter, right? So they could essentially derive a lot of insights from this dimension. Now let's take a look at the mapping table. The mapping table holds the key information for the source that we are trying to essentially map, right? So let me show you what I'm talking about. So this is again Apache Hudi mapping table. As you can see, temperature high alert would be mapped to high underscore temperature underscore alert. So this table essentially holds key information about the different event name and what it should be mapped into. So hopefully that made sense now. So now that you have seen all the three tables, that is the event table, which essentially holds the event data coming from IoT sensor devices. You saw the date dimension and also you saw the mapping table. Now let us define a simple function called upsert Hudi table, which will essentially perform an upsert operation on Apache Hudi transactional data lake. So again, I have kept it very simple. Again, the function takes a database, table name, a record ID, precom key, a Spark data frame, the table type is copy on write, method is upsert. And the job is essentially to perform an append operation on the data lake. Now you saw the helper utility method to perform an upsert. Now let's perform an upsert on the Hodi data lake. We want to make three Hodi tables. Here is the date dimension. So I'm creating Apache Hodi date dimension. I'm creating Apache Hodi mappings table. And then I'm creating Apache Hodi events table. So this basically creates three tables, that is the mapping, the events, which is the IoT devices are sending data, right? And then the date dimension. Now, what we need to do is the next step, we need to incrementally iterate over the events and then essentially perform join with the mapping and the date dimension and populate our fact table. So let's take a look at the process. So now I do have a helper method for incremental data processing and I'm going to instantiate the class. As you can see, we are going to instantiate a class called Hodi incremental reader. We are going to pass in the S3 bucket name. And again, the bucket is used for checkpointing purposes. The Hodi settings, we pass in the table name, the path and the Spark data frame. After that, we call the method called read, and essentially what this does is basically it's going to perform the incremental query and get the data into a Spark data frame into a variable incremental events underscore df. So now we have all these Spark data frame. Now what we need to do is basically we need to join the data and essentially populate our fact table. Let me show you the process for that. So over here, as you can see, I'm creating a temp view called events from the incremental data from the events table. I'm creating a temp view for the dime underscore date. This is essentially the date dimension, and also I'm doing it for the mapping. So which means I'm loading the events data in a temp view, the entire date dimension and the mappings as well. Now what we need to do is we need to join and essentially populate our fact table. Before I show you the query, I think it will make more sense if I show you the diagram. So hopefully this made sense. We have an events table which has all the events information. For example, timestamp, unique ID, event, device ID, sensor ID, mapping table which holds the information about the mapping. For example, the event name and the standardized name, right? This is the fact table that we have to populate, right? That's the query that we are writing. So the fact table will have sensor ID, device ID, date underscore key, unique ID, and the standardized name. So let's take a look at the Spark SQL. Select e.sensor ID, e.device ID, and e.unique ID, which means I am selecting sensor ID, device ID, and unique ID from the table called events, as you can see. Then we are selecting d.date underscore key, which means I'm selecting the date dimension key over here, as you can see. Now we use the word coalesces. Coalesces meaning if you find the value for m.standardized event name. So in the mapping table, we have something called standardized event name, right? So if you find the value, use that value. But if you don't find the value, use the unknown as default value. Then we essentially, as you can see, we join this on the mapping. So basically we say join the mapping table event name with essentially the event table event, right? So we basically perform a left join, and then we basically left join on the date dimension so that we can populate the date dimension key. So the output looks something like this. Hopefully this should make sense. So you have a sensor ID, device ID, date underscore key from the date dimension. So you can analyze these data over a month, over a year. You can aggregate that over a date dimension. Unique ID again from the event table, and again as you can see, standardized event. This is the standardized event basically that the business wants, right? So with this technique, you are now instead of doing the entire ETL again and again, you are essentially performing incremental ETL, meaning every time new data comes into the event table, you're gonna incrementally fetch those data using the helper method that I showed you, right? After that, you're joining that with the mapping and the date dimension, and then you're basically performing an upsert on the fact table. Now, a small tip over here for basically mappings that you do not have. So the default value would be unknown. Now you can easily write a backfilling job. So you can say, give me everything from the fact where the value is unknown. And then once you have that, then you can essentially, assuming that the mapping was updated, right, was added, you can essentially read the mappings and then update the fact table directly. Hopefully that made sense. So thank you so much for watching. This technique could be applied across a lot of amazing stuff, right? Like across lot of stuff, basically anything that you want to standardize the name, right? You can use or leverage these techniques. So store the mapping in a mapping hoodie table, right? And then incrementally iterate over your events or whatever the table you have, and then perform a join, and then perform an upsert on the fact or the model table. Thank you so very much for watching. I hope this video was useful and informative. All the resources, including a code, every single thing is given on my blog section. The links to that could be found on the description. With that being said, I hope you enjoyed. Keep smiling, stay safe, keep learning, and I'm gonna see you in the upcoming next video. And by the way, if you do have questions, please do not hesitate to leave a comment on the video. All right guys, see you in the next video.